Welcome to the Regents Physics Static Electricity problem set. We're looking today at the solutions to problems 27 through 29. Let's go ahead and get started. For 27, if 120 joules of work are performed to move 1 coulomb of charge from a positive plate to a negative plate, what potential difference exists between the plates? We're taking a look here. Your 120 joules of work would be a capital W. And then you're told 1 coulomb of charge, which would be the Q value. And you're asked for the potential difference, which they're asking for the V value. The equation that relates those three quantities is V equals W divided by Q. Your work is 120 joules. Your Q is 1 coulomb. Of course, this is 120 divided by 1, which is 120. And the units are volts for potential difference. Number 28, how much work is done to transfer 0.15 coulombs of charge through the electric potential difference of 9 volts? Same equation, but rearranged. So V is W divided by Q. W would be V times Q. We've got our 9 volt potential difference times our charge of 0.15 coulombs that is moved. 9 times 0.15 is 1.35. To 2 digits, that would be 1.4 joules. And number 29, an electron is moved through an electric potential difference of 500 volts. How much work is done on the electron? Again, same equation, V equals W divided by Q. So W would be V times Q. 500 volts times the charge of 1 electron, which is 1.60 times 10 to the negative 19 coulombs. When we multiply those, we get 8 times 10 to the negative 17 joules. The alternate way to do this, instead of substituting 1.6 times 10 to the negative 19 coulombs, is to put 1 E in here for 1 elementary charge. When you do that, of course, 500 times 1 is 500, but the unit becomes what is called an electron volt, E times V. So this answer, an alternate unit here, an alternate answer would be 500 electron volts. And electron volts is simply an alternate unit of energy that we use when dealing with small numbers of charges, and certainly 1 electron would be deemed a small number of charges. Ask more about that in class tomorrow if you're not sure understanding that concept. That value, by the way, is on the reference table. Okay, that'll do it for 27 through 29. More to come on our work with electric potential energy and electric potential when we do number 30 in class tomorrow.